Chapter 2 looks at the study of learning and behavior, or as I like to call it, research methods. I'm sure at this point you're very familiar with the structure of most psychology classes, and you've likely noticed that the second or sometimes first chapter of each class that you've taken has to do with research. Before we get into this, I want to tell you that the reason we do this is, one, to familiarize you or help you get familiar with research in the field because it is a crucial component of the field of psychology, and two, get you started critically thinking about how research methodology impacts what we actually know about psychology. While I'm going through this, I want you to pay attention to the methods being used, the terms we're using, what those mean, and how that relates to what the actual information we're learning from research is. Although I am a researcher, and I love research, and I have a lot of faith in the research process, research isn't perfect. So what I want you to do is think about what the limitations of a study might be, what the limitations of our knowledge might be. Even though we know a lot about learning and behavior, like I said, research isn't perfect, so there might be areas where we want to question things. Ask questions like, does this apply to everyone? Or what are the kind of biases that might have influenced the interpretation of this research? So keep that in mind while we're going through Chapter 2 and the rest of the semester. If you have any questions or comments, points you want to make, feel free to talk about those in your weekly discussions. Your unit discussions, email me about them. I'd be happy to talk. Video 1 of Chapter 2 is going to look at how we measure change. As I mentioned in Chapter 1, change is learning. We're going to talk about some assumptions we have of behaviors and how exactly we measure that change. And then in Video 2, we'll talk about some methodological approaches to studying learning. To get started, we need to understand what the natural science approach to learning is. Learning is a natural phenomenon. That is one of the kind of foundational facts we need to understand. Learning, as we talked about in Chapter 1, happens as a result of the natural environment. Because of that, there's 4 basic assumptions we need to talk about. Assumption 1 is that all natural phenomena are caused. They don't just randomly happen. You each took a series of steps to get where you are, to take this class, to get where you are in life right now, that caused your current situation. Assumption number 2 is that the cause always precedes their effect. The cause has to come before the outcome. Students work hard, and that allows them to get their grade. Assumption 3 is that the cause of a natural event includes only natural phenomenon. So to explain a behavior, we have to identify what biological and environmental events preceded it. This gets very complex as we get further into the class because not all behaviors have a single cause. We're going to talk about, when we talk about conditioning, how you might be targeting a behavior you want to get rid of. Maybe even think about the behavior you're considering doing for your behavioral modification project. We have to identify what the preceding behavior or the preceding event that causes that behavior might be and maybe remove it. However, a lot of the time there is a second, third, and fourth event that causes that behavior. So to truly understand a change, we have to know everything that precedes it. The last assumption is an overarching psychological assumption that we make. The simplest explanation that fits the data is the best. We're not always right, but the fewer assumptions or unconfirmed, unverified events that we make when describing a behavior, when explaining it, the better. And we call this parsimony. The simplest example or the simplest explanation is the best because there's less uncertainty. So those assumptions are important and we need to keep them in mind when we're talking about behavior and learning. However, studying learning requires a lot more than just these 4 assumptions. It requires rigorous method and application of the scientific method coupled with these assumptions. So I want you to pause the video after I give a little bit of an explanation here and take 10 minutes to do the following. I want you to design a simple experiment to test these questions. So how would you go about designing an experiment to test these questions? Do people learn psychology better by listening to lectures, reading their textbook, or both? Do first graders and sixth graders learn math the same way? Can you train dogs and cats the same way? Pause the video, take a few minutes, and maybe write out or at least think about how you would go about answering these research questions. When you're done, play the video. When you were coming up with your potential experiments to test those questions I asked you, you might have noticed that you have to figure out what to measure to answer those questions. So say I'm trying to figure out if students learn better by listening to lectures, reading a textbook, and so on and so forth. How do I measure learning? I have to actually physically be able to observe it. So because of that, we want to go over a few different behaviors you can look for that indicate that change is occurring. The first one is error, okay? I am looking to see if my lectures actually help students learn better. One way I can look at that, or look to see that, is to measure how many questions you get wrong on a test. Okay, so my dependent variable, my outcome, the thing that I'm interested in looking at to help me learn if learning is occurring, is to see if there's a reduction in errors. Another example, spelling. As I learn, I make fewer spelling mistakes and subsequently fewer errors. Another type of behavior we can look at is topography, and this is just the form a behavior takes. For example, drawing looks better the more I practice. Topography could be learning a dance, how your posture changes as you learn how to do it, how accurate your step is as you learn to do that dance. If you want more information on what topography looks like, I suggest watching this video. So we have error and we have topography. Think back to those 3 questions I asked you. Could you look at topography or error when answering these 3 questions? For example, do people learn psychology better from listening to lectures, reading their textbook, or both? I could have 3 groups that each do one of these and then look to see who misses the most questions on an exam. That's error. Do first and sixth graders learn math the same way? I could look at how they're actually doing their math. You know how you have to show your work a lot in math classes to look at the topography of that behavior. Next, we have intensity. Intensity refers to how intensely or how hard a behavior is performed. For example, if you train a rat to press a lever, how hard is the lever pressed down? Speed, how fast does the behavior occur? How fast does a rat run a maze? Rate, the number of occurrences per unit of time. Can we make a rat scratch its face less? These 3 variables also indicate learning. So take a second and think about how you could apply those 3 variables to answer these questions. Lastly, we have fluency. Fluency refers to how many correct turns or behaviors happen compared to incorrect behaviors. So thinking back to that rat running a maze example, how many correct turns does the rat make compared to incorrect turns? Fluency. Do I perform the behavior correctly more than I perform it incorrectly? It's kind of a ratio to correct and incorrect behaviors. And then we have latency, and this one's interesting. Latency refers to the period of time it takes for a stimuli to occur in the environment and the behavioral response to happen as an outcome. For example, how long does it take the rat to figure out how to run a new maze? I could potentially give you an exam and then time, how long it takes you to figure out the correct answers. That would be a measure of latency and can also indicate the extent at which learning has occurred. So, another practice question, how would you measure the following using fluency and latency? What's the best way to learn to throw a new football? What's the best way to teach math? think about those questions. If you're having a hard time coming up with an example, feel free to email me, call me, or Zoom with me during office hours, and I can help walk you through that. So, study tip for Chapter 2. Make sure you know the definitions of these terms. My suggestion here would be, in addition to just writing the definition, put it in your own words and write down an example. You might also want to pay attention to terms that you might get confused with one another and point out to yourself how they're different. This will help you understand the concepts much better and subsequently do better on the exam. That ends Chapter 2, Part 1. Chapter 2, Part 2 will look at specific methodological approaches we have for measuring and researching learning.